Good morning. In this video session we are going to learn how to design a template jig from basics using Creo Parametric 7.0.0.0. So on the left hand side you can see the component drawing. On the right hand side I have opened the Creo Parametric edition. So this is the component. We have given only the component drawing. So based on the tolerances given, we have to design a proper jig, a simple template jig, such that whatever the component is within the dimension should be able to make the holes. So our intention is to make dia for 4 holes in the range of position 0.5 in the maximum material condition. So we have to design a simple jig using the given parameters. So this is our component, some machined component. I think is 10 mm thickness, so 5 mm depth, and we have to drill 4 holes of dia 4. So let us see how to design this particular template jig. So template jig in the sense, when we look when we align the component, we should be able to locate it from some of the shapes which is available from the component, right? So let us start. So first of all we are going to open a new file. So before that we will select a working directory. So we will go here. So just create a new folder. So I'm going to give the name as template jig, jig 02. Okay, then okay. So first of all we will be making the model of this particular component. So in the tolerance range it is given for 1 decimal it is plus or minus 0.1. So we have to assume that this particular rib, it is symmetrical about the center axis. It is going to have a variation of plus 0.1 or minus 0.1 in about the center axis. So we are going to design the jig at the maximum material condition. So let us design it. So new. So I am going directly for the assembly. Then we will give a name template jig assembly, and date also we will mention. So today 10 January 21. Okay. Common name design practical 01, exercise number 0. Then I removed the check mark here, use default template, then OK. Then from here what I am going to do is I am going to select MMNS, millimeter Newton second, ASM, design, ABS, absolute, then description. Okay, what description we can give? Component, we will give the component, sorry, this is template jig, template jig, and modeled by, okay. Then okay. Now we have to first make a part, so we are going to do that. So go here, create part. The file name is component. I am giving component. Common name is product. So solid part it is, part, then okay. Oh, okay, so we will give component 01. Okay, so we will use allocate default datums, 3 planes, align coordinate system to coordinate system, then okay. Okay, so we have got the coordinate system as well as 3 planes aligned with the original plane. This is now the active part. Now we can start making the model. So directly I am going to the extrude command, extrude, on placement define, and sketching plane I am going to select this plane, then sketch. Then let us draw a circle. Okay, just a circle. Then let me place it. Oh, I think I will directly give the diameter as well. Diameter 20. And place it somewhere like this. Then we will select the particular geometry here. Then go for mirror. Select this axis. So it is mirrored. Again select both of the circle. Then go to mirror and select this axis, so that we got the allocation. Now what I am going to do is I am going to make a construction mode and draw a line from this center to this center. Again one more line. Okay, here. Okay, oh no. Okay, these 2 lines I will make. Then again I will off the construction mode. Then draw a line from this point to this point. Then go to mirror and select this construction line. One more time I will draw a line vertical to this. Then again directly it is highlighted now, so I can mirror it. Mirror, select this point. Okay, now I am directly going to mirror these 2 lines as well as the center line, so the construction line. So select both of this, press Ctrl key and select these 3 lines, then go to mirror and select this particular line. Okay, now one more time select this line, press Ctrl key and select these other lines, go to mirror and select this. Now I am going to define, I want to define this dimension, so go to just right click and select the dimension icon here, then select these 2 lines, then press a middle button. Okay, let it be there. Again similarly I am going to give here also, press a middle button, select both the lines, then press middle button, then select this center point and this center point and press middle button once again. One more time, this center point, this one, and a middle button. Okay, Now we can orient the diamond, or we can do it later also. I think it is better for us to go here, tools. Okay, it is not highlighted. Okay, don't worry, go to sketch here. Sketch. Okay, this we have to trim all these unwanted lines. Go to delete segment, select remove this the unwanted all lines. We have to trim it. Trim here as well, here as well. Okay, now all those things are completed. Now oh, some problem is there. We have to find out. Okay, I think here. Okay. This also we will trim. Okay, now it is. Now next step is we need to define all the given dimensions correctly. So what we will do is just select the entire thing, or okay, we will directly define the dimensions. It is not a big issue. So here it is 35, and this is 85. So here directly I am going to give 8.1. okay, why? Because the maximum size as per the tolerance range, the model can go up to a value 8.1 in the maximum material condition. Similarly, this also I will edit as 8.1. I can do one more thing. Okay, let us don't worry about this. So after once I completed, I can give the thickness. So I'm going here to symmetric value, and the total thickness is given as 10. So give the value 10. Then okay. Now if you look at this particular model, everywhere there is a fillet. This fillet round, as per Creo, it is round. So the radius is R4. So this this particular extrude I am going to name as base. Okay, base. Now go for round, and you select one of the edge. Don't select it, bring the cursor towards that edge, then right click, then go to pick from a list, pick from a list, then indent edge, the second one. If I go here, you can see all the edges are highlighted, which is the correct requirement for me. Okay, then give OK, then give the value as 4, so that I can select the entire thing in one particular setting. Now if you look at this particular figure, there is a diaphragm hole at 4 places, and to a depth of 5 mm. Okay, that is the without the counter the drill entry portion. We have to give drill a 5 mm distance, and it is a open dimension, so it can go plus or minus 0.5. So we will go to the medium dimension only. So before that, for making a concentric drill, I need to make a axis. Okay, so going for the axis here, then I will select this particular edge. Okay, then okay, so I made the axis. Now I can make a hole now, so go for the hole option here, hole, then placement is on this face. Okay, press Ctrl key and select the axis so that it will come to that coaxial. Then shape is standard type. Then if you go here, shape, we can define the depth as 5. So you can see here, enter. You can see here this we are going to define from this top edge to this edge 5 mm. Diameter is 4. Then we can give right click. Okay, it is done. I think we have to bring this one here and give the check mark. So as you know, this particular hole is symmetric about the planes, the center planes. So we are going to directly mirror it. So go for mirror and select this. Okay, again you select both these items, press Ctrl and select both these, then go to mirror once again, then select this plane, then OK. So we have completed the part. Okay, so component is ready now. Now we have to make the so next step is we have to make the plate. So let us design the plate, the main part of this template jig, that is template. So let us do that. So for that we have to activate this main assembly once again, then go to create, then we will be making a sub assembly for that. Sub assembly, the name is template jig assembly. Okay, 01. Common name is design practical. Sub-assembly standard we will go, then OK. Allocate default datums we will give, then OK. So we will select this. Okay. So I think now we can turn off this datum. So we will select all these things, control, select this, and we'll hide it. So we have got the datum for this one also. Next we have to activate this particular assembly. Now under this assembly we are going to create our template. So after activating this, you can go here, create. Next is part, then this is we can give template body, body 01. Okay, common name is design practical. Then okay, locate default datums, align coordinate system to coordinate system, then okay. Then select the coordinate system. So now this is active. Now I think what we will do is we will offset a plane slightly away from this face so that we can start the sketching. So just select this face, then give a value or translation 5 mm translation, then okay. So we got a new plane here, so you can see it is there. Now I'm going directly for extrude. Then what I'm going to do is I'm going to make a center rectangle, because my product is symmetric about center rectangle, and click first on the center, then just draw a rectangle. Then here I will make this I think 120 dimension will be okay for me. This is something like 80 will be okay. Okay, now first let me extrude this particular path. Then right click, then give the tick mark. Then height, what we will do, we will give something like 15 mm or 12 mm. I think 12 mm will be okay. 12 mm we will give, then okay. 12 mm. Then what I want to do is I want to make the chamfer on all the edges. So go to chamfer, then select one of the edge and right click, pick from the list, then edge, okay, I can choose like this. So intended edge is the right one, you can see 4 edges are selected, then okay, then 4 mm chamfer I am going to give 4 mm, then tick. Similarly I want to give the chamfer on the other 4 edges as well. So again go for chamfer. This time I will change the value to be 1 mm, value to be 1, enter. Then again I will do the same thing, right click, pick from the list, okay, then okay. So now this is the thing I want, okay. Apart from that I want to add these other 4 corners as well. So press Ctrl key and select this edge, select this edge, also select this edge, okay. One more thing, I want to add this also, okay. So press Ctrl key, select this, right click, pick from the list, so go here, so it is also got selected, then okay. Then press Ctrl key again and add these other edges as well. So this chamfer is very important because we are going to hold the template by our hand, on our hand, right? So it is done. So next thing is that we need locating pins. So for positioning the locating pins, what we will do, we will make some holes on this part. Okay, I think it will be better to make some blind holes. Okay, we'll make some through hole. Okay, don't worry. So for that, again select this face, then extrude, then we will simply draw one circle on this line, another one somewhere here, both are equal. Okay, and one more I want here. Okay, so automatically the relation is there. So this diameter we will make as 6 mm, that it be 6. Then we will make tangent relation, tangency constraint with this and this edge, this here, also here. Right. Now we want to mirror both these circles towards the other side. So press a middle button, then select this circle, control and select this circle, then go to mirror and select this. Now we can select the dimension and select this, both these points, and press the middle button. So I think we will go for 58 will be okay, so that 60 also okay, we will go for 60. Okay, make sure that it is having, okay, it's a line contact, so no problem. So other all dimensions are already defined. Okay, then right click, then give a tick mark. So I want to change the direction, so I can click here. Then here I am going to give through all. Then okay. So I made the hole. Now one more thing, on this plate I want to make the jig bushing. So what I will do, I will make the rest button as a jig bush. Okay, so that I can ensure that it is resting properly, the contact area is less, as well as it will work as a guide bush also. So for that, first we will make a hole. So diameter is 4. So 12 mm hole we will make on this plate. So again go for extrude, select this face, then we will simply draw a circle, one circle here, and this is let us make it 12. Okay, then we will select this, then go for mirror. Okay, again both press Ctrl key and select both the circle, then go for mirror and select on the other side as well. Then right click, give the check mark, then flip the direction, then here I will give all, then okay. Now I want to give a small chamfer for the holes. So let us do that. Go for chamfer. So this we will change to 0.5. 0.5 is okay. The small chamfer. Pick from the list. Let me see what are all the things I am getting. Face, surface, indent edge. So I am getting this. Then okay. Again press Ctrl key and select, right click, pick from the list. So okay, so I'm getting all those. Then go here again, press Control, right click, pick from the list. So I'm getting all the selections. Then okay, again press Control, right click here, pick from the list. Then okay, I'm getting all these 5. Then okay, then tick OK. So I made the chamfer also for all the holes. Now next part is first we will design the rest button together with jig bush. Okay, so we will activate this once again, and we will go for create part. So this is the name is jig bush with jig bush button will do. Okay, now the name is jig bush button. Okay, then okay, so this is locate datum, default to datums, and align coordinate system to coordinate system. I think it is not required. 3 planes only we will give. Then okay, then select the, go and select the coordinate system. Okay, we will select this Y. Okay, let me okay, I think now it is selected. Jig bush button part. So we need to design the button now. So what we will do, we will expand this. Okay, before that what I will do, I will rename the template body, activate this body, and here this is our base, okay, and this chamfer is plate edge chamfers, plate edge. This is corner. Okay, plate edge. Okay, this one is plate face, then this is locating pin hole. This is bush or jig bush hole. Okay, this chamfer is hole chamfer. So now we will activate this particular part. So what we are going to do, we are going to just see what is the direction. Oh, Control D, like this. So now what we will do is we will create a plane over here, plane, through this axis, press Ctrl and select this plane, then we will give a parallel, then OK. And on this plane we are going to make a revolve. So axis is there, so I'm going to make one center line here. Let us make a center line, then just draw the shape. Okay, I think we will project this. Let us see. Go to project. So this one I am projecting, and this edge I am projecting, and this edge also I am projecting it. Okay, now I will draw the line. Okay, let it be like this. So from here also we will do that, and here also we will project it. Okay. Let us project. Close. Now I want all to remove the unwanted portions. So this I don't want, this I don't want, this here I don't want, this here I don't want. Still okay, this also I don't want. Okay, I will trim this also I don't want. Okay, now I got a closed curve. Now one more thing I want to do, that is I want to give a small undercut here, so that what I'm going to do, I'm going to make center and ends. Then let me trim this as well. Okay, now it is I think why not we make the other shape also. So what I'm going to do is I'm going to just draw this like this. Let me draw something like this. Okay, let me make coincident with this, and I want to define the dimension. So this to this to this, I want 4. Now I want to remove all the those unwanted portions I want to remove. Okay, now it is better. So here we will make something like 3.5. This we can give something like 10 is enough. Okay. Now let us finish it. What is the problem? Okay, I think here some problem is there. We'll remove the unwanted lines here also. Okay, now let us check. Okay, now it is done. Okay, So now this is our jig bush button. So this is the body. It's the body. Okay. So this bush button will act both as rest button as well as jig bush, right? So we can again activate this, activate. Oh, I think there is some problem interfering segment, so let me go edit once again. Okay, so that sketch I want to edit it. Let me remove this. So this I want to remove. This diameter is something like 12. Okay, so this let me delete. This also I will delete. Okay, so this diameter from here to this point. It is I know 12. Okay, some problem is there. Okay, this is the one causing the problem here. Okay, let me remove this as well. Okay, now let me edit this 12. Then we will draw center arc. Okay, let it draw somewhere else. Coincident and making this coincident with this point again. So this we will make 1 or 0.5. Coincident here also we will make this coincident, and tangent, this we will make tangent. So this we will make 0.75. So this is 12 and this 4. We have made this. Then the outer dimension is, I think it is not moving. Okay, so we can give a tick mark, so it is okay. Done. So now I forgot one thing here, that is, as per our requirement, we need some geometry to see on this plate. So I'm going to make the internal profile also on this plate, because when I locate the component by this plate, I want to see easily that it is located properly. So what I'm going to do is I'm going to select this face then extrude, I'm going for extrude, then I'm going to select the project, then for loop, so just select this face, then you just click next. So you can see now the internal edge is highlighted blue, so you can click accept, close, then right click, tick mark, flip the direction, then all, then OK. Now what I will do, this also we will rename it, that is profile, template profile, we will say template profile. Okay, that is done. Now next thing is that we'll activate this assembly. One more locating pin also we need to add. So just add a few locating pins. So create part. This is say pin locator. Solid, everything is okay. Common name is jig or practical design practical. Okay. So this also we will use it as it is, then OK. Then we will go here and select any of the datum here. Now simply what we will do is we will go for extrude and select this face, then it is asking for some reference, so we will select this coordinate system here, close. Now we will again go for project and chain we will go, we will select, then internal edge I will select, then press Ctrl and select the next immediate edge, press Ctrl and select the it's not accepting. Okay, we will go for single and select this edge and this edge. Close. Now we can right click, then give a check mark, then 5 mm already we have to give. After that again we will give some 6 and 7 mm, so 12 mm we will give, 12 here, 12, and on the other side not to selected blind, blind, and options. Okay, side 2 first we will give blind, then give some value. Okay, let it be, I think here some problem is there, 12, let us reverse it. So the total height is 12, so we will give something like 10 mm. Then side to blind, so this we will give as 12. Enter. Okay, so this will be all right. Then give a tick mark. Then so round, we will give some 1 mm round here, so this we will give 1. Okay, then on the other side we will give a chamfer. I think we will go for D1 into D2, and here D1 give 2 and D2 sorry, D1 we will give 1, 0.5 we will give D1 0.5, D1 0.5, and D2 something like 2 mm. Okay, or okay, that will be okay. Tick. So we have done that. So everything is now we will activate this particular thing. Then we will assemble the remaining parts. So you can go here, assemble. Okay, I think we need to, okay, pin locator, open. Then first what we will do, we will make a constraint. So this face with this face, we will flip it, not distance, this is coincident, we'll flip it. Okay, then on the placement, new constraint, we'll select this particular face with this face. So this is allow assumptions, we can give tick. Again one more thing, assemble, same thing, pin locator, open. Then you can go here, select this face, and this face is coincident, flip direction, then this face and this cylindrical face. Okay. Again assemble, pin locator, open. You can go here, select this face and this face, coincident, then go to placement, new constraint, then okay, coincident, I think flip it, sorry, so this one we will flip it, then this face with this face, allow assumptions. Okay. Then again one more, assemble, open, this face to this face, so this coincident, sorry, not normal, coincident, flip it, placement, new constraint, this to this. Okay, so 1 2 5 locators are there. Now we have to assemble this one. So assemble, so we need to cancel. Let us save this first. Save all, file, save. Okay, let us save it. Save. Jig bush button, we have to get it. Go to assemble, jig bush button, open. Then first what we will do, we will give automatic constraint this face to this face. Okay. Then placement new constraint this face, cylindrical face. Then okay, again assemble, open this placement new constraint this to this. Tick. One more, assemble, open this to this face, this face, this face, tick. So now we can see that. Now we will save. So regenerate, save. Okay, now we can activate this and let us so now you can see that this is our template jig, and appearance, you change the appearance. Go here, some more appearances, color wheel, we will go here. Okay, then appearance. This one we have changed it to new appearance. Another one we will change this to this one. Okay. 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 Another one more appearance I will take. Which one? I think we will select this for this. Okay. Select this for this. Okay. Okay, like this we can change the color so that it will appear nice. Okay, so Control D, if I select Control D, I can see that the design is complete. So we can locate the part as well as we can use this concept to design the jig. Okay, so thank you, thanks for watching. So this is our template jig.